So having established the rational numbers are fractions, let us now go a step deeper to this. I've established that fraction exists like this, right? Now there are two main types of fraction, two main categories of types of fraction. You have decimal fractions and common fractions. Decimal fractions and common fractions. Decimal fractions and common fractions. What are decimal fractions? Decimal fractions are fractions with what? Decimal what? No long story. So that means decimal fractions are fractions with what? But not. Listen carefully. Take this rule. Fractions can have the decimal point, but not all numbers with decimal point are fractions. Fractions can be expressed as decimals. Are you with me? But not all decimal numbers are what? Fractions. Because not all of them are rationalized, can be rationalized. So not all. Do you now see where the term you did solve now, right? Yes. You see where the term rationalization came from. A surd, like root 3. Root 3 is a surd. Root 3 can never give you, it can give you a decimal number, but it cannot give you a what? Fraction. It's not a fraction because it's not rational. That's why they say rationalization of what? It's to make it rational. You rationalize it because a surd is not a rational number, even though it can exist as what? Decimal number. If you find root 3, you wanted the decimal number, but it's not rational. No. That's why they say that they want to rationalize the what? So that's the understanding of what you've been doing. What you did in your first year to rationalize it. So you want to make it a rational number. So not all the numbers that have decimal points are rational numbers. But rational numbers can be expressed as common fraction or as a what? Decimal fraction. So decimal fractions have what? Decimal points. Common fraction have what? Fractional line with numerator and what? Denominator. So if you want to convert a common fraction to a decimal fraction, all you need to do is to do what? Divide the numerator with the what? Denominator, and find your what? Common fraction. That's why if you do 1/2 is a common fraction, right? But it has the same value of what? 0.5. This is a common fraction. This is a decimal fraction. This 0.5 is discrete. It's rational. You can define where it is here. It's not continuous. It's not continuous. Are you with me? It's not continuous. You can define where it is. 0.75 is what? Discrete. It's not continuous. You can fix it here and end it. So that means 3/4 is what? 3/4, they have the same value. 3/4 is a rational number. It's a common fraction expressed as decimal fraction, which is what? 0.7. By just dividing the numerator with the what? Denominator. Am I communicating? Good. Now let's talk a bit about what decimal what fraction. There are decimal fractions. We have I'm almost asleep. Next, are you with us? You look lost. Okay, now let's continue. In decimal fraction, we have terminating decimal and recurring decimal. We have terminating decimal and recurring decimal. Terminating, yes.
And what?
Recurring. We have terminating decimal and recurring decimals. Two of them are still rational numbers. Essentially. Recurring is something that is recurring decimal. Browsing. Because decimal and terminating or decimal. This is a terminating decimal. Fraction. We have fraction, decimal fraction. We have terminating decimal fraction and recurring decimal fraction. Now see what I mean by terminating decimal fraction. Watch. 1/2. If you divide it, to give what?
0.5.
It's terminating. It will stop that. 3/4 is what? Can I clean here?
Yes.
1/2 is what? 0.5. It's terminating decimal. Decimal fraction. So if you say decimal, it can be rational and it should. Say decimal fraction. Okay? Then 3/4 is what? 3/4 is what? 0.175 is what? Terminating decimal. It has stopped. It's not. Then let's do 1/3 is what? 1 divided by 3 is 0, right? Is 0 remainder what? 1. You times it by the base. It becomes 10, right? 10 divided by 3. 3. Remember what? Remember what? 1. You times it by the base. 10 divided by 3. Remember 1. 10. 3. 9. 3. 3. 3. 3. 3. It's something. Okay, let's go. 2/3 is what? 2/3 is 0. Remember what? 2 times the base 20 divided by 3. 6. Remember what? 2 times the base 20 divided again 6. 6. 6. 6. 6. 6. Are you with me? Now we also have there's a type that don't follow this pattern. There's a type that will follow a particular pattern and stop and go back again. You may have for like 4 digits, it will stop and go back to start from the beginning again. Let's try 3/7. Let's see what you can get. 3/7 is what? 0. Remember. Leave calculator alone. Leave calculator. 3/7 is what? 0. Remember 3. Multiply by the base. 30. Divided by 7. By 7.
4.
4, remember what? 2. Multiply by the base.
20.
Divided by 7. 2, remember what? 2, remember what? 6. Multiply by the base. 60. 60 divided by 7 is what? 8. 8. 8 remember what? 8 remember what?
No, it's like
60 divided by 7 is what? Is 8, right? Not any point again. I'm coming. Is what? 8.
it's made up 4.
8 remember what?
4.
4. Because 57 times is so now 4 times the base, which is 10 up here. 40. Divided by 7 is what? 5 remember what? Huh? 5 remember what? 5 are good.
5.
So times 10, 50. Divided by 7. Remember what?
1.
Times 10.
That's 1. Divided by 7.
10 divided by 7.
1.
1. Remember, okay, times again.
That's 4.
Calm down. Eh?
4.
4.
30 now 4.
4, remember what? 2. Times by the base.
That's 14. That's 20.
20 divided by 7.
That's
2, remember what? 20 divided by... Leave calculator alone. 20 divided by 7 is what?
6.
Huh?
6.
20 divided by 7 is what?
14. That's
2, remember what? 6. Times 10.
That's 8.
8, remember what?
4.
4 times 10.
4.
40 divided by 7.
That's
5.
5.
This is 8, right?
5.
5, remember what?
That's made of 5.
Times 10.
That's 7.
50 divided by 7.
That's 7.
Again, punch at the record
It's what
and check this number again.
That's what
Ever applicable here? Right? Did you not see anything here? Look at this number. It stopped here. I started again.
from 1.
If you keep doing it, once you get to 1, it's again. Calling again, it's calling back. Are you with me? So this is a what? But there are some decimals you punch. You can never, if you punch with 3, it will scatter. It's scattered, it's not recorded. So it's not a fraction. You know a rational number. Are you with me? Are you with me? Please you think this just is for you to have a bit exposure in all this. Maybe if you have come across it, you recall your, Alright, please, I think we'll stop here on this. Any question? Any question?
You said that is not a fractional.
Do what?
Rational number.
Which one? So, no, it's not. It's not. It's rational. It's rational. It's also under continuous number. It's irrational number. It's not what continuous number. Are you with me? Irrational number. That's why you have here 3, pi, sort, generally. Then pi, blah blah blah. Pi is an irrational number. Even though mathematically they tell you that pi is 22/7, pi is not 22/7. The real value of pi is not 22. If you press 22/7, 22/7 is recurring. But the real value of pi is not recurring. Google it. They look alike. But if Google the real value of pi, not to do myself. That thing was given to you at a secondary school level. Let's keep going.
This use 3.1.
Use 3.1.
It's 3.1. Not that.
But we are using pi to what to do myself. I forgot it. So I'm thinking that pi is not to do myself by value. But if you check it, they look alike. See, hello, studies, academics is level by level. When you were in primary school, did you know that there's anything like minus one? Primary one. Or one. But even till now, some of you having issues with when you go to minus, the best institution. Which one is one? So in learning, there's a level you reach, you unlearn to learn. You unlearn to learn. If you carry that thing you are giving in primary school, you keep having issues up and down. There's a level you unlearn to learn again. Because they cannot give you everything at that stage. You can't carry it. So some small truth you will told small truth. As you come again, you do that go to the because of the level is step by step. You will be doing additions. You will be doing addition. From nowhere, I think you what S 2x plus 1. What is your 2x plus 1? Divide it. It's confusion up and down. It's step by one. Now, please, let's continue.
Yes.
So that means 2x plus 1.
Yeah, yes, it is. It is. Pi is 73 points. But pi itself is not your calling. Google value of pi.
Is it now?
Anytime you want to do it.
It's 3 points. It's your calling.
Google.
Oh, that's not the value of pi. Just say value of pi. Just Google value of pi. Value of pi. Just Google value of pi. Not to do myself. Even though they look alike. So now, when we go to continuous number, remember we've been talking about for discrete numbers, right? When we now go to continuous number. Okay, sorry, we are not dealing with fractions. We just talked about common and decimal fraction, right? Now let's talk about common fraction. In common fraction, we have different types of common fraction, right? We have their what? Proper fraction. Common fraction is fraction that is expressed in this form, A over B. Common fraction is the fraction expressed in this form, A over B. Are you with me? Where A is what? Numerator. B is what? And the line is what? Is it recording? Value of pi. It's not recording. It's not recording. But yeah, what if you check it, it look like 20%. But at a point you see that it's not recording. But 20% is recording. But in your comments, they will tell you value of pi as. No, if you accumulate it, they look alike. But if you trace the real number, if you trace the number full, then they are not the same thing. So this any number in this form A over B, where A is the numerator, B is the what numerator is a common word fraction. But remember, A can be what, but B can never be what. And A and B are what? Integers. That means they can be positive integer or what? True or false? That's why you can say minus 2 over minus what? 4. Give you what? Give you what?
1 over 2.
Minus will cancel minus. Are these not negative integers? Negative integers. Am I communicating? So now, types of common fraction, we have proper fraction. We have proper fraction. Proper fraction. What's a proper fraction? What's a proper fraction? What is a proper fraction? Remember, common fraction is expressed in this form. So, proper fraction is a fraction in which the numerator is less than the what? That's a proper fraction. Numerator is less than the what? Denominator. That's a proper fraction. Improper fraction, example, you have your what? 1 over what? 2, 3 over what? 4. You can look for more examples, okay? In improper fraction, the numerator is greater than the what? The numerator is greater than the what? Denominator. That's an improper fraction. Something like this.
14 over 2. 14 over 5.
Is what? Into over what? 3. 4 over what? These are what? Improper what? Fractions. Improper what? Fractions. Then we have mixed fraction. A mixed fraction has what? A whole number and what? And the what? Proper fraction. A mixed fraction contains a whole number and a what? Proper what? Fraction. An improper fraction is unstable. Is unstable. So if you solve and get to and have an improper fraction, don't leave the result like that. Change it to what? Mixed fraction. An improper fraction is unstable. So that means as you are solving, when you get to you answer result to an improper fraction. Not even like that. Try to bring it down to what? Mixed fraction. Mixed fraction example. 1 whole number, 2 over what? Okay. Let's use this one as a mixed fraction. Let's convert it. Let's convert this to a mixed fraction. 4 over 5 should give us 4 over what? 5. This is a mixed fraction. It has a whole number and what? This one will come 2 number what?
2 over 3 over 3.
This is also a what? Mixed fraction. This one will come
1 over 3.
good. You can still convert this back to what? Improper fraction if you want, okay? This times this is what? 10. Plus 4 is what? 14. This time this is what? 6. Plus 2?
8.
This time this?
3. 4.
Is it clear? So these are the major. There are many other the other ones, but these are the major ones. Let us not waste our time. You can Google, browse. I just open your eyes to some areas you may not have dream about. So you can on your own expand, learn more, and develop yourself. Now I've already said that I think with this now we have actually done much on discrete numbers, right?
Yeah.
Now let us conclude with what? Continuous number. Of course, I have told you that they are here, but they are what? Continuous. Are you with me? Are you with me? Most of them are what? Irrational what? Numbers. Example, sword is irrational. Are you with me? Sword is what? Irrational. Sword is pi a sword?
No.
But pi is irrational. Are you with me? Sword is irrational. Swords like root 2, root 3, root 5, root 7, root 11, 30. These are what? Irrational. But you may have a sword that is not a basic sword, I hope you know. Not when you see root what? 24. Root 24 is not a root of a perfect square. But you say because it is not the root of a perfect square, you conclude. No, try to bring it down to the basic sword first. Because here you can have 8 times what? You can you also have 4 times 2 times 8. So you can have root 4, root 2, root what? Root what? Right? 4 times 2 times 3. This will give you what? 2. Root what? 6. This is basic sword here now. True of us? So be careful before you conclude. The sword here now that is irrational is what? 6. We are not. Let's come back. This is where we are now. Now, this is what I say that this is now our what? Irrational. So pi is also irrational. Find out more. Are you with me?
Yes, sir.
Value of pi still falls between here. True of us? True of us? It still falls between here, right? Good. Between 4 and 3. True of us?
True.
Value of pi falls between 4 and what?
3.
Because it's 3 point blah 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 blah. Now, there's in imaginary numbers. Let me just say one or two things. Imaginary numbers, example of an imaginary number, they normally come with I. Have you ever seen a number like this? I. What do you mean of I? Root minus 1. There's another group of numbers called complex numbers. Complex numbers. Complex numbers is a combination of real number and imaginary number. So it's not here, but I just mentioned it so that you know that such number exists. Let me just. Can I clean here now? I said that complex number, no matter how this, they can have this. The value of this is what? I agree. So that means you can have 2I. 2 what? I agree. 2I. So that means a number in this form, this is an imaginary number. 2I is an imaginary number. So a complex number is a combination of what? Real number and what? And what? Imaginary what? This is an example of what? Imaginary what? No. But I is minus root 1. So that means a number in this form, a plus bi, is a complex number. So if you can have 3 plus 2I is a complex number. 3 minus 2I is a complex number. Just want to let you know that such number exists. But we don't use that more in your area here. Those in engineering know this more. Although that deep into mathematics know this more. Are you with me? So let's stop here on this. Let us not go further. You know, there are some things that you need to know that exist, but you don't know where it's sitting. It can be mentioned. At least you know that it is, even though you don't know it deep, but you know that such thing what exists. It's very important, okay? Okay, you want to go? Should we stop here?
Yes.
First time. 3, 4. When do we start this lecture? Nothing no problem and your tire. Okay. Please. Now let me tell you something. In our next class, we will start with numerals. Yes, you just mention that. Huh? I shall do. Please, hello, answer.